Problem 15. Let p of x equal x to the fourth plus ax cubed plus bx squared plus cx plus d. Here a, b, c, and d are given real numbers. If p1 equals 1993, p of 2 equals 3986, and p of 3 equals 5979, what is 1/4 of p of 11 plus p of -7? So when you're given some big numbers, there are two things to do. Either just assume they're random, or maybe they actually fall into a pattern. So I'm going to give an example. So there was this AMC problem this year. It was AMC2. And AMC is another math contest you go to after AMC10. So there's the AMC problem that said something about 200 and then 2000 and then said something about 1099. So it was suspicious from the beginning why it would be this kind of number. And then once you realize that this number is one less than the average of 200 and 2000, you can have an easier time. Yeah. So that was that. So let's see. This might not be completely random, especially when there's more than one number. When there's one number, it's probably random, but when there are multiple, it's not necessarily. So you notice this is close to 2000, this is close to 4000, and this is close to 6000. And it seems like they're all just a bit less. But this is very close. This is just a bit less, and then this is even more or less. So let's see if we can multiply something, because multiplication makes them like 2 times 9 is farther away from 20 than 1 times 9 is quite close to 10. 2 times 9 is not as close to 20. So it turns out that 3986 is 2 times 1993, and then 5979 is 3 times 1993. So there's p of 1 equals 1993. P of 2 equals 1993 times 2, and then P of 3 equals 1993 times 3. So let's build a new equation based on this, our new polynomial. P of 1 equals 1993 times 1. P of 2 equals 1993 times 2, and then P of 3 equals 1993 times 3. So how about we say Q of x equals P of x minus 1993x. That would mean P of 1 minus 1993 times 1 would be 0. And then Q of 2 would be 0. Q of 3 would be 0. So then Q of x, let's think about it a bit further. So we know that it has to have roots 1, 2, and 3. So it has to be divisible by this polynomial. And we also know that it's P of x is a degree 4 polynomial. So Q of x must also be a degree 4 polynomial, since this linear term doesn't increase or decrease the degree. So Q of x has to be in the form of something like this, x minus the other roots r. But then we also know that the leading coefficient of P of x, we see that it is 1. So the leading coefficient of p of x minus 1993x should also be 1. So we don't need this a term right here. It's definitely 1. So we know that this is the case. Now let's evaluate what this is. 1/4 of p of 11 plus p of negative 7. So 1/4 of p of 11. P of 11 is equal to q of 11. And then plus 1993 times 11. Just by this definition, but then we add 1993x to both sides. And then we also have plus q of negative 7, plus q of negative 7 minus 1993 times, this time it's 7, minus 1993 times 7. This time was plus 11, this minus 7, So 1993 times 11 minus 1993 times 7 is just 1993 times 4. Then you take 1/4 of that, that's just 1993. And then you add 1/4 of q of 11 plus q of negative 7. So we know that this polynomial q can be written in the form at the bottom. So let's write it in that form. 1/4 times q of 11, which is just 11 minus 1 times 11 minus 2 times 11 minus 3, and then times 11 minus r. And then plus, actually, no, this parenthesis shouldn't be there. So q of negative 7 is negative 7 minus 1, negative 8, times negative 7 minus 2, negative 9, times negative 7 minus 3, negative 10, times negative 7 minus r. So, this is a parentheses. So what you realize is this is 10 times 9 times 8. This is negative 8 times negative 9 times negative 10. So that's exactly the negative of 10 times 9 times 8. So we get 1993 plus 1/4 of 10 times 9 times 8 times 11 minus r. And then instead of plus, this becomes a minus, but then the other minus signs all become pluses. 8, or maybe I should say 10 times 9 times 8 times negative 7 minus r. So that's equal to 1993 plus 1/4 of 10 times 9 times 8, 10 times 9 times 8, and then times 11 minus r minus parentheses minus 7 minus r. So that is 18. So then we cancel the 1/4 with the 8th and change it to 2. And then this is 3,240, this thing. So then 1,993 plus 3,240 is 5,233. Problem 16. In triangle ABC, sine of A is equal to 3/5 and sine of B is equal to 5/13. If angle C is less than 30 degrees and sine of C equals m over n with two coprime positive integers m and n, what is m plus n? Okay, so first, let's use the fact that A plus B plus C equals 180 degrees. So to calculate sine C, we can have C is equal to 180 minus A minus B. Then sine, take the sine of both sides, we get sine of C is equal to sine of 180 minus A minus B. Yeah, so then let's look at the unit circle. Yeah, so we can show that sine of something is equal to sine of 180 minus that thing because these perpendiculars are the same length. So sine of 180 minus A minus B is equal to sine A plus B. So we can use the angle addition formulas to get sine of A times cosine B plus sine B times cosine A. So we know that sine A is equal to 3/5. And then we know that cosine sine of B is equal to 5/13. So what are cosine A and cosine B? So using the Pythagorean identity, you'll get cosine A squared plus sine A squared equals 1. So plugging sine A equals 3/5, we get cosine of A equals plus minus 4/5 cosine of A. And then cosine of B, we can do the same thing and we'll get plus or minus 12/13. So now, which one is it? So we're given that C is less than 30 degrees. So let's look at the unit circle again. What can A be? So we know sine A is 3/5, so A must either be this point or this point, which has both have altitudes 3/5. And then B must have sine of 5/13, so either here or there. And then we want A plus B to be equal to 180 minus C. Since C is less than 30 degrees, that means in the range of 150 to 180. Yeah. So how do we do that? Well, first, let's see how we can assign A and B so that it will add up to that range. If A was this and B was this, then no. How about if A was still that, but then B was that? then it would go past 180 degrees. And then what if A and B were both on the left side? Then that would go a lot past 180 degrees. So it has to be like this. A is there, B is there. So in this case, A has negative 4/5 cosine theta, cosine A, and then B has positive 12/13 for cosine B. So we can plug that into our equation, and then we'll get 3 times 12 is 36, 5 times 13 is 65, and then minus negative, which minus 5 times 4, 20 over 65, so that's 16 over 65, and the answer is 16 plus 65, which is 81. In case you were wondering why C is less than 30, we can just take this cosine, this sine of 16 over 65, and we can prove that it has to be less than 30, because the sine of 30 is 1/2, and sine is an increasing function all the way from 0 to 90. So 16 over 65 is less than 1/2, so the angle C must be less than 30. Problem 17. Z1 and Z2 are two complex solutions to z squared minus az plus 1 equals 0. Here A is a real number. If Z1, Z2, and 2 form an equilateral triangle on the complex plane, what is A? So you see a quadratic with real coefficients, and you see that there are two complex solutions to it. There's a well-known theorem that you should memorize that says that for any polynomial with real coefficients, its complex roots must come in conjugate pairs. So Z2 is the conjugate of Z1. So what else do you know about this? It says z squared minus az plus 1. So you already know the constant term. And the constant term is the product of the two roots by Vieta's formulas. So it's equal to z1 times z2, which is equal to z1 times z1 conjugate, which is, this is actually just equal to the magnitude of z1 squared, and it's 1. So the magnitude of z1 is equal to 1. So z1 is on the coordinate plane. So let's draw that. A unit circle on the complex plane, I mean. On the unit circle. So this is 2. This is z1. And then z2 must be the conjugate, so it's reflected over the x-axis, so it must also be on the unit circle. So now it says, if z1, z2, and 2 form an equilateral triangle on the complex plane. So how about, let's just draw those 30-degree rays coming from 2 and then intersecting the unit circle. We need to know where it intersects. And if you got some intuition that this problem must have only one answer, then you'll know that you'll guessed that it will be tangent, and you're right. So this is tangent, but it's not really that good to guess in a competition, even though it really saves you time. It's good, but it's not too good for learning new things. And I could totally have just used the equation of this line to come up with the intersection point, but this is faster. So let's assume that this is tangent, and we'll see that everything works well. So this is a 90 degree. So this is 60. So then this is 2, and this is supposed to be 1. But then this is supposed to be 1. It's the unit circle. So this works, and it is tangent. So now let's zoom in a little bit on the unit circle. We don't need to worry about 2. We know this is 60 degrees. So yeah, let's just remember that, and I'm gonna draw this bigger now. So Z1 is on the 60 degree thing, and then Z2 is right here on the negative 60 degree thing. So to find A, first we have to find Z1 and Z2, but not really. We just need to find their sum, and that's A by Vietta's formulas. So their sum, adding head to tail, tail to head, we get this. So it is at 1. So A is actually just equal to 1. Problem 18. If 2x squared plus x minus 1 over x squared times x minus 1 is equal to a over x plus b over x squared plus c over x minus 1 for 3 constants a, b, and c, what is a plus b plus c? Okay, so this is a partial fraction decomposition, but you don't really have to know that. All you need to know is we should just multiply to get rid of the fractions. So we multiply in this case by x squared times x minus 1. So the left-hand side is 2x squared plus x minus 11. The right-hand side is, so a times x minus 1. And then b times x minus 1, and then c times x squared. So if you look at this a bit, you'll see that only b can have the constant term. A has this thing, which doesn't have any constant term, and c has x squared, which isn't a constant term. So the b part is bx minus b. So we have to have minus b equal to minus 11. So b equals 11. So now we can get rid of one variable. We'll have a times x minus 1 plus 11x minus 11 plus cx squared equals 2x squared plus x minus 11. So let's simplify it. We'll get ax times x minus 1 plus cx squared equals 2x squared minus 10x. So now, once you look at this a bit more, you'll see that a has the x term, x times negative 1, but c doesn't. So the a part is just ax squared minus ax. So that would mean minus ax equals negative 10x. So then a equals 10. So we can simplify this even more. We'll get 10x squared minus 10x plus cx squared is equal to 2x squared minus 10x. And then we simplify it to get cx squared equals negative 8x squared. Everything else cancels, so c equals negative 8. And we see that a plus b plus c is 10 plus 11 minus 8, which is equal to 13. Problem 19. A certain set contains all numbers whose digits are a permutation of the numbers 1, 2, 3, 4, 5, 6. Let Pn be the nth smallest number in that set. What is the average of the numbers P2, P4, P6, all the way to P720? So, first note that there are 720, 6 factorial equals 720 numbers that satisfy this property. So it's telling us to find the average of all the even numbers, the ones with even indices, I mean. So how about let's look at what happens if we first find all the average of all the numbers, including the odd and even indices. So we want P1 plus P2 plus P3 plus all the way to P720. So the key idea here is we can pair up those, like just like we do in arithmetic series. That's the motivation. Plus 720, we pair up this, and then we pair up that, and then we find how many there are, and then we add them all up. So just like suppose P1 is 1, 2, 3, 4, 5, 6, the smallest. And P720 is 6, 5, 4, 3, 2, 1, the biggest. So if you add them up, you'll get 7, 7, 7, 7, 7, 7. Similarly, if you take something like 3, 1, 5, 6, 4, 2, then let's try to make them to also add up to 7, 7, 7, 7, 7, 7. Then we can just use the number that comes when you get subtracted from 7. Like, so 7 minus 2 is 5, so this is a 5. 7 minus 4 is 3, so this is 3. 7 minus 6 is 1. 7 minus 5 is 2. 7 minus 1 is 6. 7 minus 3 is 4. So you use these. So that's one thing that we can find. So let's actually find it. So the sum of each pair is 7, 7, 7, 7, 7, 7, and there are 360 pairs. So the total is 7, 7, 7, 7, 7, 7 times 360. So if you look at the problem, it implies that it's not really making you calculate all this. It says, what is the average? So there's going to be some dividing later. Now, we know the average of everything, or we know the sum of everything, and we can calculate the average easily. It just is divided by 720, which is 7777777 over 2. So if you think about it though, the P2, P4, P6 ones are just gonna be a bit more than the P1, P3, P5, P7, all the way to P719. So how much more? That's the question that you should be asking yourself. So let's think about it a little. We know that the sum of all those numbers is that. But how about the sum of the evens only? So how about let's denote the sum of all the even numbers, not the average, but the sum as A. And then the sum of all the odd indices, the sum of all the odd indice numbers is B. So we can already say that A plus B is that, the total sum. But how about A minus B? We want to know how much difference there is between those. So A minus B is just P2 plus P4 plus dot 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 plus P720 minus P1 minus P3 minus P5 dot 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 minus P719. So we can just pair them up and let's analyze the individual differences and then let's sum them all up in the end. So we get this. And then what is their difference? So let's try to find a bit more patterns between the numbers. So P1 is 1, 2, 3, 4, 5, 6. The smallest you can make for P2 is if you switch the last two digits, because the last two digits don't matter as much. And then after that, it's 1, 2, 3, 5, 4, 6. And then after that, the last two digits need to get switched. So 1, 2, 3, 5, 6, 4. So you might be realizing a pattern here. The first four digits of each group, I would say, like each group would be the same. So only the last two digits, we need to take the difference of the last two digits. But what is the difference? So by these examples, 65 minus 56 equals 9. 64 minus 46 equals 18. So it seems like multiples of 9. But when are they multiples of 9? And which multiples of 9 also? So let's now just do it in variables. Suppose A, B are digits. So we want to find AB minus BA, the two-digit numbers AB minus two-digit number BA. So we can write this as 10A plus B minus 10B plus A. So that's equal to 9A minus 9B. So it's 9 times the difference between A and B. So now we know what to find. So for each of them, the difference between the last two digits times 9 is their total difference. So let's see then, how many ways are there to choose A and B such that their difference is 1, for example? Well, it can be 2, 1, 3, 2, 4, 3, 5, 4, and 6, 5. So there are 5 ways of doing it. And then we need to add the other 4 digits with 4 factorial ways because there's only the order now. So 4 factorial times 5 times, we need to multiply it by that 9 right there. And then what do we do? After that, let's try the case for 2's. So the case for 2's, there are 3, 1, 4, 2, 5, 3, and 6, 4. So there are 4 of them. So there's still 4 factorial for the first 4 digits, and then it's 4 instead of 5. But then now a minus b is 2 instead of 1. The last time a minus b was 1, so we just omitted it because it wasn't any difference. So then we need to add a 2, and then there's still that extra multiplier of 9. And then you can see where this is going. So 4 factorial times 3 times 3 times 9, then plus 4 factorial times 2 times 4 times 9 plus 4 factorial times 1 times 5 times 9. So you can see that this whole thing is just 4 factorial times 9 times all this stuff. So if you calculate that, it becomes 4 factorial times 9 is 24 times 9, which is 216. And then the sum of all those is 5 plus 6, 5 plus 8 plus 9 plus 8 plus 5, which is 35. So that's just basically, if you multiply a 5 here and then you take out a 5 here, it becomes 1080 times 7. And then if you take out a 3 here and then you add a 3 here, it becomes 360 times 21. So now we know a minus b is 360 times 21. So a minus b equals 360 times 21. A plus b, we know it's 777,777 times 20 times 360. 360. So now we can find a finally. So we add up those two to get 2a equals 360 times 777,798. So a equals 360 times 388,899. Yes. After some calculation. And then, so it's asking for not the sum, but the average. So we need to divide it by the number of elements are in A. So there are 360. So all the evens from 2 to 720. So our final answer is 388,899. Problem 20. A point P is chosen on diagonal AC of square ABCD with side length 2 such that PC is less than or equal to PA. Let O1 and O2 be the centers of the circumcircle of ABC and ABP and CDP respectively. If O1PO2 is equal to 120 degrees, what is the sum of the area of the two circumcircles? So, yeah, maybe you were thinking about cyclic quadrilaterals. Maybe you were thinking about some other things. Those are all great ideas. But this problem actually uses one of the most basic definitions of circumcenter. It's just the intersection of the perpendicular bisectors. So which ones am I talking about? This one is a perpendicular bisector. And then this one is also a perpendicular bisector. And also you can use these. And it's gonna be useful to connect those two because this is a square and you can do that thing because everything's parallel and stuff. So it would be nice if you can know the dimensions of the triangle O1PO2. So you can actually do it that way. So first, it would be nice to find the distance between O1 and O2. So let's try that. Oh, so there's this thing right here if you look carefully. And this looks like it has all 45-degree angles, and that's not hard to prove. So we can actually draw an extension that meets this line right here. But why is this useful? Well, it actually turns out that, so here's a rectangle. But what is the length of this line? Well, you know that this part is exactly half of, exactly the same as that part, and then this part is exactly the same as that part. So this is actually a half of the diagonal. The diagonal has length 2√2, so it has length √2. But then that's a rectangle, so that means this will also have length √2. But then that would mean this would be that times √2, which would be 2. Oh, do you see anything special in that number? Well, I see something. The square is also side length 2. So you'll actually find that this thing is a parallelogram, to be more rigorous. The intuition here is that if you can transform this triangle into this triangle by a translation, then that would mean that AO1 is equal to DO2. And we can also prove that by the parallelogram because of just the properties of the parallelogram. So the two radii are actually the same. So what are they? So we know that O1, O2, the distance is 2, and then we know that there's a 120-degree angle right here. So we can just divide it into two 30, 60, 90 triangles, this being 60 and that being 30. So then this becomes 1, this is 1. So then this is 1 over √3, which is √3 over 3. So then this thing, the height is √3 over 3. So then PO2 or PO1 would be 2√3 over 3. So then you can just say that the areas of the circumcircles are pi r squared plus pi r squared again. And r is just that. So pi times 2√3 over 3 squared plus pi times 2 root 3 over 3 squared. So that is equal to pi times, this is 4 over 3 plus, again, another pi times 4 over 3, which is equal to 8 over 3 pi. So that is the answer. So that's it for the explanation. I hope you enjoyed it. I hope you learned something out of it. And have a nice day. Bye, everyone.